This is a very short, fairly short video. It's how to recognize the difference between a nonlinear function and a function. A nonlinear function would basically be any other function but a line. So the characteristics are, the very first characteristic you look at when you look at a graph, it's not a straight line. As soon as it's not a straight line, it's a nonlinear function. Secondly, it doesn't have a constant rate of change, meaning its slopes are different. It doesn't have the same slope. Some slopes are positive, some slopes are negative, some slopes are steeper, some slopes are less steep. They're different. And you can't write it in the form f of x equals mx plus b. There's no constant slope, no constant y-intercept. There are many, infinitely many different functions. Here are just a few basic ones. So the first one is your basic square function, right? That's a parabola shape. It's non-linear, because again it's a square term, it doesn't have just an x term, there's a square in there. And its rate of change are different. Over here would have negative slopes, and on this side we have positive slopes. And they're small here, these would be small slopes, and they'd get bigger as I move down. And so my slopes aren't constant. The easiest thing is to tell the shape, but again, it's non-linear because it's not a constant slope. A root function. Again, there's a root in it. There's no roots allowed in linear functions. It's not a line. It's got a slight curve to it. Now, in this case, all my slopes would be positive, but they are getting smaller, right? It's becoming less and less steep. And so all my slopes are actually different. Alright, I've got different rates of growth as I move down my line there, as I'm moving down my curve. And again, it's obviously not a straight line, it's got a curve to it, and there's a root in my function. Basic cube root, same idea, again, not a line, there's this kink in the middle, and again, it curves. Which means the slopes are really big here, they get smaller until they actually hit 0, and then they get really big again. Right, so the slopes are all different. Right, the absolute value function is kind of like the parabola. Again, absolute value of x. If I didn't have the absolute value, it would be a line. But since we throw the absolute value in, it's not a line. Over here would be a negative slope. Over here would be a positive slope. Right, so slopes are different. You can't write it in mx plus b. Just looking at, again, determining, you can always graph them. You can get out your graphing calculator and graph these if you need to see them. Or you can graph your just by hand if you want to plot some points and graph it and see what the shape looks like. I'm missing a function here. But it should be fairly obvious. It's anything other than mx plus b. It's non-linear. So the first one is fine. The m would be negative 2, the b would be plus 3, so yes, that's linear. The next one is the square root of x plus, as soon as you see the square root, not linear. Alright, if you graphed it, it would be this shape. It would have a parabola, half a parabola shape. Right, you have a curve to it. Negative 10. These are the ones that are tricky. This is, remember, our constant. This is our constant linear function. Alright, slope would be 0, y-intercept would be negative 10. And so it is a y equals mx plus b. M is just 0. Right? It would be f of x equals 0, x minus 10. It's a horizontal line, so it is a line. If you graphed it, it would be a flat line at y equals negative 10. And a flat line's fine. Vertical lines are also fine. Alright, a vertical line's also linear. It's not a function, though. It's just linear. It is a line, but it's not a function. Right, absolute value of x, again, as soon as we see absolute value, if I could drop the absolute value, it's linear. But as soon as I add the absolute value, this is non-linear. If you graphed it, it has that V shape. It's not a line. And the last one, again, as soon as you've got a square, this is a parabola shape. Right, this is a parabola. If you graphed it, it would look something like this. This parabola opens down because you got a negative on the square term. And so this one's also non-linear. Alright, so it's just a quick what's linear and non-linear, because we're going to look at non-linear functions here and talk about increase, decrease, and since we can't find slope, that's calculus that does that. What we can do is, well, we can find an average slope, an average rate of change, and so that's what we're going to do and talk about with the remaining videos here in 1.4.